In this video, we are going to see about the valence bond theory in octahedral complexes. Now, before we come to the examples, we can divide ligands into two types, strong ligands and weak ligands. The actual explanation about the strong and weak ligands is coming in the next theory of bonding, that is crystal field theory, and it was found in crystal field theory, that is classification of ligands as strong and weak ligands. But if we know that strong and weak ligands examples, it's easy for us to identify the type of hybridization on the basis of valence bond theory. So I'm going to write the examples of strong ligands and weak ligands. So we are going to discuss about the valence bond theory for octahedral complexes. Octahedral complexes means complexes whose coordination number is equal to 6. So first we are going to see about the strong ligands and weak ligands. Now example 4, strong ligands. Now when you study valence bond theory, you just need to study the examples. Now what are strong ligands, weak ligands, what is their role and all, you will learn in the next theory, that is crystal field theory. Now the example for strong ligand is ammonia, NO2 minus, CN minus, CO carbonyl group, EN ethane 1,2-diamine and oxalate ion. So these are the examples for strong ligands. Now example 4, weak ligands. Weak ligands. Weak ligands are all halide ions, I minus, Br minus, Cl minus, then OH minus, thiocyanate ion and H2O. So these are the examples for weak ligands, strong ligands and weak ligands. Now, we are going to study the hybridization in octahedral complexes, and we know that in octahedral complexes we have octahedral complexes. OH is the short form for octahedral complexes. We have the coordination number as 6, and the two possible hybridization in octahedral complexes are D2sp3 and sp3d2. And what is the shape of octahedral complexes? Shape is octahedral. Okay. Now, we are going to see the examples involving strong ligands and weak ligands. Now, by looking at the ligand, in case of octahedral complexes, by looking at the ligand, that is if it's a strong or a weak ligand, we can predict the type of hybridization. That is, whether it is D2sp3 or sp3d2. That is, if it's a strong ligand, then pairing takes place. Pairing of what? Pairing of electrons take place. In that case, the hybridization is D2sp3 and the complex formed is low spin or inner orbital complex. So study this, very important. If it's a strong ligand, we saw the examples for strong ligands, cyanide ion, ammonia, ethane 1,2-diamine, oxalate ion, all these are strong ligands. If it's a strong ligand, then pairing of electron takes place in the d orbital of the metal, and the hybridization is D2sp3, and you can see it is D2sp3. D2 means it is the inner d orbital participating in hybridization. That is our 3d orbital. So what will be the type of complex form? It will be a low spin or inner orbital or spin paired complex is formed. Now if it's a weak ligand, then no pairing of electrons will not take place. In that case, the hybridization is sp3d2 and they form high spin or outer orbital complex. High spin or outer orbital complex. So if it's a weak ligand, halide ions, H2O, OH minus, in that case, no pairing of electrons in d orbital takes place, which means which orbital is involved in hybridization? Outer d orbital. That is, our 4d orbital is involved in hybridization. And what will be the hybridization? sp3d2. And what type of complex is formed? High spin or outer orbital or spin free complexes are formed. So if you look at this d2 sp3 sp3 d2, when you see d2 sp3, it is the 3d orbital involved in hybridization, and sp3 d2, the hybridization, the orbital involved is 4d orbital. So this is something very important. This you have to learn, very, very important, before we study the example. Strong ligand pairing d2sp3 and low spin or inner orbital complex is formed. Weak ligand, no pairing, sp3d2 and high spin or outer orbital complex is formed. Now let us see the examples for bonding in octahedral complexes. So usual question asked is this: discuss the nature of bonding in this compound. One compound will be given based on valence bond theory. Okay, so we have to show the bonding in coordination compound. So we are going to see the examples. So we have example 1, that is bonding in octahedral complexes. Example 1, this is for coordination number 6. Now the first example is CONH3 6 times 3 plus. Now before we show that steps for hybridization, even without writing the steps, we can predict the hybridization based on this. That is, what is this? Look at the ligand. What is the ligand here? Ammonia. And we know that ammonia is a strong ligand. So strong ligand means what will happen? Pairing takes place, and what will be the hybridization? D2 sp3. And what type of complex is formed? Low spin or inner orbital complex. But we have to prove that this compound undergoes D2 sp3 hybridization. So we have to write steps and prove. So first is to find the oxidation number of the central metal atom and write its electronic configuration. So the central metal atom is cobalt, and cobalt, what is oxidation number? X plus 0 is equal to plus 3. So what is oxidation number of cobalt? Cobalt is in 3 plus oxidation state. Okay. Now write the electronic configuration of cobalt atom in ground state. So first you find the oxidation number of central atom. Now the step 1, first step is the cobalt atom in ground state. Now what is the configuration of cobalt atom in ground state? Cobalt atom in ground state configuration is argon. Cobalt is 3d7 4s2. 3d7 4s2. Now you draw the orbital diagram. You know how to draw the orbital diagram, that is in square boxes. It is 3d7 4s2. So we have 1, 2, 3, 4, 5. This is our 3d orbital, 4s, and also you draw 4p orbital. Okay, so draw 3d, 4s, 4p. Now show the distribution of electron. 3d7 means 1, 2, 3, 4, 5. And we know according to Hund's rule, pairing takes place after each orbital is singly occupied. So 5, now 2 more electrons, so 6, 7. 4s2. So that is the first step. Now next you are going to write the electronic configuration of CO3 plus ion. So next you are going to write CO3 plus ion, that is the metal ion. So what is the configuration of metal ion? 3 plus means 3 electrons are lost. So first 2 electrons are removed from 4s orbital and the third electron is removed from 3d orbital. So what will be the configuration? 3d6. This is the configuration. Now show the orbital diagram, and it's very compulsory that when you draw the orbital diagram for the ground state, write the name of the orbitals, that is 3d, 4s, 4p. Now next steps and all, we did not write the name, but that's very important. At least once that name should be written of the orbitals. Now 3d6 means 1, 2, 3, 4, 5, 4s, 4p. Now 1, 2, 3, 4, 5 and 6. Okay, so this is the orbital diagram of cobalt 3 plus ion. Now next step, third step is to check the ligand. Our ligand is ammonia. So ammonia being a strong ligand, what will happen? Pairing of electron takes place in d orbital. How is that pairing taking place in d orbital? This electron will jump to this position. So this orbital is free. Now this will jump to this position and this electron also will jump to this position, leaving 2 vacant d orbitals. So next step, you have to write what the ammonia being a strong ligand, pairing of electron takes place. Okay, and we got the hybridization. What is the hybridization? D2sp3 hybridization. So next step, we will write ammonia being a strong ligand, pairing of electron takes place. And you got the hybridization also. If pairing is there, you know it is D2sp3. So next step is you have to write D2sp3 hybrid orbitals of CO3 plus. Now you are going to show the orbitals. Now here no need to write the configuration again, just you have to show the orbital diagram. So how will you show that orbital diagram? After this 1, 2, 3, 4, 5, 4s, 4p. Now 1, 2, 3, 4, 5, 6. Now which is the D2sp3 hybrid orbitals? This is the D2sp3 hybrid orbitals. This is D2, this is 4s and 4p. So this is the hybrid orbitals which are empty. Now what will happen in the next step? These hybrid orbitals will overlap with the ligand orbitals which donate electron pair and results in the formation of coordinate bond. So the last step is the formation of when you show, you need to write only this explanation. If asked, you have to write, explain and write. So formation of the complex, which is that complex CONH3 6 times 3 plus. So how will you show the formation of the complex? Again, you have to draw. Now here. Now you are going to show the electrons from ligands. Now what is this? These are the 6 pairs of electrons from how many ammonia molecule? 6 ammonia molecule. That is our ligand. The ligand donates electron pairs to the vacant orbitals or the D2sp3 hybrid orbital of CO3 plus ion. So this is how you show the hybridization on the basis of valence bond theory. So I'll explain this again. First you have to find the central atom oxidation state. Now the first step is this, that is cobalt atom in ground state. Write the configuration and show the orbital diagram. Now second is you have to write the configuration of the metal ion and show the diagram. Third is to check the ligand and find out if it's a strong or weak ligand, and the sentence is very, very important. It has to be written. Now next, once you get whether it's a strong or weak ligand, you get to know the type of hybridization. So next step is write D2sp3 hybrid orbitals of CO3 plus and show the formation of D2sp3 hybrid orbitals. And the last step is the formation of the compound, that is the ligand donating lone pair of electrons to the vacant orbital or hybrid orbital of the metal ion, and as a result coordinate bond is formed. Now after this you have to write three things. The first thing is you have to write the hybridization. What is the hybridization of this complex? D2sp3. Next you have to write the shape. What is the shape of the complex? Octahedral. Now next you have to write whether it is diamagnetic or paramagnetic. Now to check that, you have to check the last step, that is formation of the complex. Now you look at these orbitals, they are completely filled with no unpaired electrons. Okay, so is it dia or paramagnetic? Diamagnetic with no unpaired electrons. So the third thing that you have to write is it is diamagnetic with no unpaired electron. Whenever you write the word diamagnetic, write with no unpaired electron. Now one more thing you have to write, that is whether it is an inner orbital or outer orbital complex. Here which d orbital is involved in hybridization? Inner d orbital. So what is it? This is an inner orbital complex. Inner orbital complex, or is it a high spin or low spin complex? Inner orbital or low spin complex. Low spin means, so here the spin is 0 because it is diamagnetic. Okay, so the number of unpaired electrons, if it is more, it will be high spin complex, or else it's a low spin complex. And we know inner orbital complexes are low spin complexes. So these four informations we have to write after each explanation of the bonding in coordination compounds. So this is the first example. Now next example, next question is example 2. Same way we have to show. Example 2. FeCN 6 times 4 minus. Now you have to show the bonding in this complex. Now again check the electronic oxidation state of the central atom ion. So here we have x minus 6. So x minus 6 is equal to minus 4. X will be equal to plus minus 4 plus 6 will be plus 2. So ion is in 2 plus oxidation state. Okay. Now next step, what is the first step? First step is to write the electronic configuration of the atom in ground state. So how will you write it? Iron atom in ground state. Now what is the configuration of iron atom in ground state? Argon 3d6 4s2. Now draw the orbital diagram. 3d 4s 4p. 3d 4s 4p. 3d6 means one electron will enter after that pairing takes place. This is 3d6 and 4s2. Now the next step is to write the metal ion, that is Fe2 plus ion. So Fe2 plus ion, what is the configuration? Argon 3d6. 2 electrons are removed from 4s orbital. Now draw the orbital diagram. So 3d6, 1, 2, 3, 4, 5, 6. Now next step is to check the ligand. The question is FeCN 6 times 4 minus. The ligand is cyanide ion. Again, it's a very strong ligand. So pairing of electrons take place. So what you have to write in the next step? Cn minus being a strong ligand. Pairing of electron takes place. Okay, now next you have to write which hybridization. So pairing takes place means how is that pairing taking place? This will jump to this orbital, this is vacant, now both will jump to this orbital. So next step is D2. Again hybridization is D2 sp3 hybrid orbital of which ion? Fe2 plus. So how will you show that D2 sp3 hybrid orbital? Again 4s 4 1 2 3 4 5 6 and show that D2 sp3 hybrid orbital. This is the hybrid orbital. D2 sp3 hybrid orbital. Now next is the formation of the complex. Last step is formation of, what was the complex? FeCN 6 times 4 minus. So how will you show that formation? Here we have, now to this orbital the lone pair of electrons from ligand, the cyanide ion, will enter. So these are 6 pairs of electron or 6 electron pairs from 6 Cn minus ions. Okay, now next you have to write the 4 informations. What are the 4 informations? First one is hybridization, which is D2 sp3. Shape is octahedral. Now, what about the paramagnetic character or magnetic character? It is diamagnetic. Look here, no unpaired electrons, so diamagnetic. And whenever you write diamagnetic with no unpaired electron. Now next is diamagnetic with no unpaired electron, and last you have to write about the spin. Now inner d orbital is involved, so we have inner orbital or spin paired complex. So this is a inner orbital or low spin complex. 4 informations. Okay, so this was our second example. Now one more example we have again. So whenever the question is asked to explain, you have to show the orbital diagram, electronic configuration like this, and write the informations. Now one more example, that is example 3. CO, C2O4 thrice 3 minus. Now I am not going to show this, but we will explain it. We know that, look, without writing the steps, we can predict what is the hybridization. It's oxalate ion, which is strong ligand. So what will happen? Pairing takes place. So what will be the hybridization? D2sp3, shape is octahedral. Now we should know whether it is diamagnetic or paramagnetic. For that, you have to write just that electronic configurations, not all the steps I am going to do. We are going to check whether the compound is diamagnetic or paramagnetic. So look here, cobalt electronic configuration, we have to find oxidation state X minus 2. So X minus 6 is equal to minus 3, X is equal to plus 3, which means cobalt is in 3 plus oxidation state. Now next I am going to write the electronic configuration of cobalt in ground state. What is the configuration? Argon 3d 7 4s2. After iron comes cobalt. So 3d 7 4s2. Now next, the electronic configuration of CO3 plus ion. No need to draw the molecular orbital diagram. The electronic configuration is argon 3d6. Okay. Now we know that the hybridization is D2sp3. Now 3d6 means 1, 2, 3, 4, 5, 6. And you know that it's a strong ligand. So again what happens? Pairing takes place. This will jump to this to this, and this to this. So you check, is there any unpaired electron in this metal ion? No, which means that this compound is diamagnetic. Okay, so what are the informations that we can write about this compound? The informations are hybridization. Hybridization is D2sp3 since the ligand is strong. Then shape is octahedral. Now next is, it is also diamagnetic with no unpaired electron. And is it a low spin or high spin complex? This is a low spin complex and the inner orbital or low spin complex. So even without writing the steps, we can predict all the 4 informations. Okay, only to find whether it's dia or para, we just have to check it by writing the electronic configuration of the metal ion. So we explained 3 examples under bonding in octahedral complexes. Thank you.